know that the deep polar oceans have enough heat to boil thousands of gallons of water. Now you probably wonder why this heat doesn't come up to the surface and melts all the sea ice. Well, this is the question that I have been addressing for the last 6 years. During my PhD, I studied the Arctic Ocean, and here at FSU, I switched hemispheres and studied the Southern Ocean. So why is sea ice important? This shiny sea ice reflects a high portion of the solar radiation back into space. As sea ice melts, more open ocean is there for the sun's energy, and the upper water column is heated by the sun. This accelerates warming of the polar oceans, as well as warming of our climate. Now, let's take a look at the structure of the Southern Ocean. The southernmost waters from the Pacific, Atlantic, and Indian Oceans flow to the south and then they circulate around Antarctica. This forms the Southern Ocean, and that's the plan view, or horizontal. Now, what's happening in vertical? Both Arctic and the Southern Ocean have such structure that warm and salty waters are below cold and fresh waters. Let's take a look at the cross-section, let's say through here. So this figure shows many details, but I would like you to focus on the big picture. So on the y-axis, I show depth, and on the x-axis, I show latitude. Here is Antarctica, and then warm and salty layer is shown in brown, below cold and fresh layer shown in light blue. And there is this sea ice that will melt if all this heat is brought up to the surface. So why doesn't it happen? Well, we're all familiar with convection. Convection is a physical process when a heated fluid is moving away from the source of heat. In this example, the source of heat is fire. In the example of the Southern Ocean, the source of heat is these warm waters coming from the Atlantic, Pacific, and Indian Oceans. So why this warm water doesn't come up to the surface? Seawater is salty, and the presence of salt limits this rising motion. And in fact, the presence of salt in some regions of the Southern Ocean forms layers. Here you see a typical vertical structure of the upper ocean in this region. So we see many layers, and you may think of them as a many-layer cake. Our group at FSU went to this region of the Southern Ocean and took measurements under sea ice. Those are brand new observations. Using theory and numerical models, we showed that sea ice forms only when these layers are present in the upper ocean. There are no ice if there are no layers in the ocean. Basically, no cake, no icing. Our results contribute to the better understanding of the feedback mechanism between ice production and vertical mixing in the polar oceans. Or in a broader context, our results help to understand how sea ice forms and how it is distributed. This improves climate modeling and helps us understand how the planet regulates its temperature. Thank you.